Let's take a look at more electricity questions. This multiple choice question reads, the diagram below represents a circuit in which all the external resistors have the same resistance. Which one of the ammeters in the circuit will have the lowest reading? Okay, now let's just follow the path that the current will take. So this is going to represent the total current, and then it reaches a point where it's going to branch. So here's one branch, and here's another branch. Those two branches will then join up, and then we'll have the total current again. So A1 and A4 definitely will not have the lowest reading. It's between A2 and A3. Now if you look at A2, there is one resistor, and in A3, there's two resistors in that branch. Now current takes the path of least resistance. So the green path has a lower resistance. Therefore, more current will go through A2 and less current will go through A3. So the answer is C. If you like videos like this and you want to see more, be sure to hit that like button, share and subscribe. Now let's take a look at this long question. A battery of EMF 12 volts and internal resistance 0.2 ohms is connected to 3 resistors, a voltmeter, 2 switches, an ammeter, connecting wires, etc. They give us the diagram so we can have a look at it. They also tell us that the resistance of Ry is twice the resistance of Rx. So I'm going to call this X and I'm going to call that 2X. They also tell us that when both the switches are closed, the reading on the ammeter is 5.5 amperes. So this is 5.5. Then 8.1 says, give a reason why there is no current flowing through resistor Rz. So if we go and follow the current right through here, the current will split at that parallel branch. It will join up back here. But the current will go through S1 instead of going through Rz because that represents a path of least resistance. Then let's move on to 8.2. Calculate the resistance of Ry. Now to calculate the resistance of Ry, the first thing I'm going to do is I'm going to work out what my parallel combination is. And remember, since no current goes through Rz, the parallel combination is going to be the total resistance. So R parallel is going to equal product over sum. So 2x times x divided by 2x plus x. Let's simplify. So 2x squared divided by 3x. And then lastly, we can cancel the x, giving us 2 over 3x. So that's the parallel combination. That's the resistance of the circuit. Then we can actually work out the value for Ry using the EMF formula. So EMF is equal to the current into big R plus small r. The EMF is 12, the current is 5.5, and the R value is 2 over 3x, and then plus 0.2. We can then solve for x, and x is 2,97 ohms. So that means that this resistor Rx is 2,97 ohms. That means that Ry is going to be double that, which is going to be 5,95 ohms. Let's just make a note of it quickly. So right here, 5,95 ohms. Okay, let's move on to question 8.3. Question 8.3 reads, calculate the power dissipated by Rx. Now to calculate the power, I'm going to use the formula I squared times R. I don't know the current, but I can work it out. And I know Rx is 2,97. Now let's look at how we can calculate the current. So to work out the current, I'm going to use just a dividing method. So here I have my two resistors, like so. This one we worked out was 2,97. This one we worked out was 5,95. Basically, the ratio is 2 to 1. And then we have the total current of 5,5 amperes. Now we want to divide that 5,5 amperes in a ratio of 2 to 1. So basically what we have to do is add them up. So 2 plus 1 is 3. And 5.5 divided by 3 which is 1,83 amps. Now this 1,83 amps is going to go through the higher resistor, because remember, current takes the path of least resistance. So here is going to be 1,83 amps, and the balance is going to go through here. And the balance then works out to 3,67 amps. Now that we know the current, we can substitute and solve the power. So 3,67 squared, and then the power gives us 40 watts. All right, next bit of information. When both switches are opened, the reading on the ammeter is 1.3 amperes. Okay, so when both switches are open, that means the current is going to flow through here, right through here, down there, and there. And now the total current here is 1.3 amperes. The question reads, calculate the reading on the voltmeter. So 8.4, V is equal to I times R. The voltmeter is connected across RY. RX is not in play because the switch is open. So current 1.3, resistance 5,95. That gives us an answer of 7,74 volts. Next, switch S1 is opened while S2 is now closed. Okay, so now we have our parallel branch back. So here's our parallel branch, and we have our two different pathways. Now they want to know, calculate the reading on the ammeter. Now to calculate the reading on the ammeter, the first thing I want to do is I want to work out what RZ is. And to work out what RZ is, I'm going to go back to the previous bit of information that they gave us. And that's when S1 and S2 were open. When S1 and S2 were opened, my total resistance only consisted of RY and RZ. So 5,95 plus whatever RZ was. Now let's use the EMF formula. EMF is equal to I into big R plus small r. 12 is equal to 1,3, and then big R plus 0,2. We can then work out what the total resistance was when both switches were open. And the total resistance is 9,03. Now that 9,03 goes here, and that's equal to 5,95 plus RZ. We can then work out RZ, and RZ will be 3,08 ohms. Now that we know what RZ is, we can then work out the total resistance and then get our current. So RZ is 3,08 ohms. Now let's work out our total resistance. Now this is when S1 only is open. When S1 is open, my total resistance is going to be my parallel combination plus my series combination. Now parallel combination is 2 over 3 and then X. We worked out X as 2,97. So 2 over 3, then 2,97 plus the series, which is RZ, 3,08, and that gives us 5,06 ohms. Then we go to our EMF formula. EMF is I into big R plus small r. 12 equals I into 5.06 plus 0.2. We then solve for I equals 2,28 amperes. And that's it. Thanks for watching. I hope you found this useful. If you did, leave a like, share, and subscribe. I'll see you in the next video. Bye-bye.